Well, hello and welcome. And today we're going to do a little thermodynamics cycle analysis, and we're going to start with air conditioning. And what I'd like to do first is to talk about what an air conditioning system does and a little bit of how it works. So typically when you have an air conditioning system, this is also true of a refrigerator, you have two spaces, and you're trying to transfer heat from one space to another. Usually you're trying to transfer heat from a hot space to a, let me say that again. You're trying to transfer heat from a cold space to a hot space. Think of your house in the summertime. Your house is 70 degrees. That's a nice temperature in the summer. But outside it's 90 degrees. Now, all by itself, heat is coming into your house, just through conduction through the walls, but also a variety of other ways. Heat is coming into your house, and so this temperature wants to go up. For us to keep that temperature from going up, we have to transfer heat out. So we're transferring heat from a cold to a hot. That's opposite of how it wants to do it by itself. So we need a system to do it. Now this system is made up of four components. Let me show you these components. One component is a heat exchanger. And what we do here is we take energy from the room and put it into our working fluid, and our working fluid is the other fluid in the heat exchanger. So we want energy to come out of the room in the form of heat and go into this fluid. Then what we do is we compress the fluid in a compressor. And when we compress it, it goes from being cold, so naturally the temperature of this fluid when it enters here might be, well, let's just pick a number, 25 degrees Fahrenheit. So if your room is 70 degrees and the fluid in here is 25 degrees, energy is going to come into the fluid, heat is going to come in. So it comes in at 25, it actually goes out at 25. Now how can that be? Oh, good answer. It's because it's going through the vapor dome. So we can have fluid at 25 degrees in the vapor dome, have a bunch of heat go into it, and have it move across the vapor dome. Now this is the neat part. When you compress it, when you change it from being a low pressure to being a high pressure, not only does its pressure go up, but so does its temperature. In fact, the temperature could go up as high as like 120 degrees. And that's done just by compressing it. Now, let's have another heat exchanger. And in this heat exchanger, we blow air from the outside, where it's hot, across this coil. Now the air is 90 degrees. The coolant in the coil is 120 degrees. What's going to happen? Heat is going to come out of the fluid and go into the surroundings. That is cool. And that's really the essence of a refrigerator. In a refrigerator, the inside of the fridge is cold, and we take energy from the inside of the fridge and put it into the coil. Then we run it through the compressor, And now we come outside the fridge. This is on the back of the fridge. And if you ever stick your hand on the back of a fridge, how does it feel? It feels really hot. And so the heat inside the coolant is transferred from the back of the refrigerator into your house. Or for my air conditioner outside, I can hear it running right now. It's a hot temperature fluid, and it is giving heat off to the outside air. So there are 3 energy conversions taking place here. Let me find a good color. Oh, go with this pen. Now, remember, we always like to talk about the working fluid, what's happening to the working fluid. It has heat coming in to the working fluid. So whether you use a little Q in or a Q dot in, there's heat coming into the fluid. And what does a compressor do? It does work on the fluid. Work on. And then we take heat out of the fluid. Rate of heat transfer out or specific heat transfer out. Wow, that's pretty sweet. Let me check and see how much time we have here. Oh, we've got lots of time. Let's draw this on the temperature entropy diagram. Okay. To do that, I'm going to label some points. So let's call the stuff that comes into the compressor point 1, and the stuff that comes out of the compressor point 2, and the stuff that comes out of this heat exchanger, we're going to call that point 3. And then we haven't quite closed the loop here. We're going to wait to do that, but we'll call the stuff going into this heat exchanger point 4. Now I'm going to go over, I'm just going to move this off to the side, and I'm going to draw a quick temperature entropy diagram. And on my temperature entropy diagram, we've got a low pressure, we've got a high pressure, and this is point 1. This is just before things enter the compressor, and in the compressor they go from low pressure to high pressure. So point 2 is just after the compressor, and that's where the work on is taking place. From point 2 to point 3, we're taking heat out. Well, we know if you take heat out, you move backwards. You move from right to left on the temperature entropy diagram, and we usually end up right there for point 3. How convenient is that we go into this heat exchanger at a high pressure, high temperature, and we come out right at saturated liquid. What is happening to the fluid there? Is it evaporating or is it condensing? Condensing. Very good. It is condensing. So, you know what we call this heat exchanger? We call it the condenser. Now, I'm still not going to deal between 3 and 4. So I'm going to come back to 1 and work my way backwards from 1. Backwards from 1, what happened to the fluid? Heat came in. Well, I'm going to tell you that point 4, where you enter that heat exchanger, where we enter this heat exchanger, point 4, is right about here. And we put heat in. It's Q in. So we know that we move to the right. And we know from our last video how to calculate how much Q was in here or how much Q was out there. We know those things. So this is cool. Now, we called this temperature. We said this temperature is 25 degrees. So this stuff entered at 25, and it evaporated, it vaporized, and it left at 25. So there are two special points here. One is that point 1 is on the vapor dome as a saturated vapor, and point 3 is on the vapor dome as a saturated liquid. Point 2 is right above point 1. We call that an isentropic process. That means entropy stayed the same. We're going to talk through this again. The coolant comes in at point 4 and it evaporates or it vaporizes to point 1. Oh, I bet you don't know what we call this heat exchanger. The evaporator. That's where the heat comes in and the liquid vaporizes. Then the compressor, where we go from low pressure to high pressure, low pressure to high pressure, and then the condenser, where we transfer heat out. The condenser, where we transfer heat out. So this is the evaporator, and this is the condenser. Evaporator, Q in, condenser, Q out. All right, I've put it off long enough. We need to talk about what happens between points 3 and point 4. The only thing we want to have happen between point 3 and point 4 is for the pressure to drop. That's all we want. The whole purpose of this last device, it's the 4th device, its whole purpose is to have the pressure drop. Does anybody know how to have pressure in a fluid drop? Does head loss work to have pressure in a fluid drop? Yes, it does. Friction. Friction in a fluid causes head loss, causes the pressure to drop. And the best way to do that, the best way to have friction in a fluid, is by having a valve that has a very tortuous path. And we call this valve, and it is a valve, we call it the expansion valve. The expansion valve causes the fluid to go from high pressure to low pressure, huge amount of head loss, lots and lots of head loss, and there's friction. And we know what's happening here. Pressure is dropping, but friction causes entropy to go up. So this 4th device, there is no moving part. The only thing moving is the fluid. The valve isn't moving, so there's no work being done. There's no heat transfer. It is just the throttling. Two different names for it. I'm going to call it the expansion valve. So there it is. We have now identified the 4 processes in an air conditioning or refrigeration cycle: a condenser, an evaporator, a compressor, and an expansion valve. We take heat out of the cold refrigerator or house and transfer it into the hot outside, or in the outside of the house or the outside of the refrigerator. And it's a unique and I think pretty neat cycle. But what we've done now is we've just looked at what it is and how it works. In the next video, we will look at how do you analyze it. How do you find how much heat goes in, how much work goes on, and how much heat goes out. See you on the flip side.